You use AI every single day. ChatGPT that reads your files, Cursor that edits your code, Perplexity that answers with real sources, Claude that plugs straight into your apps. And here's the thing almost nobody can tell you. Under the hood, they all run on the exact same machine. Five parts, snapping together in the same order every single time. Most explanations throw these at you as scary, disconnected buzzwords. Embeddings, vector databases, RAG, MCP, agents. By the end of this video, you'll watch them click into one machine and you'll understand how modern AI actually works better than 99% of the engineers building with it. No math, no jargon. Let's build it, one piece at a time. Start with the part you already know, the large language model, the brain. It's genuinely brilliant. It can write, reason, and code. But on its own, that brain is trapped in a jar. It has amnesia. It forgets everything the moment your chat ends. It's frozen in time, stuck on the day its training stopped. So it knows nothing about this week, your company, or you. It can't see your private files, and it can't actually do anything. It can only talk. So the whole story of modern AI is really one question. How do we take this genius in a jar and give it memory, knowledge, and hands? Everything else in this video is an answer to that. 5 upgrades. Let's bolt on the first. Upgrade 1. Embeddings. This is the keystone. Understand this, and the next 3 parts basically explain themselves. Computers don't understand words, they understand numbers. So, an embedding is a way to turn any piece of text into a list of numbers, not random numbers. Numbers that capture what the text actually means. The name for that list is a vector. Think of it like map coordinates. Just like a city has a latitude and longitude that pin it to one spot on Earth, an embedding pins a sentence to one spot on a giant map of meaning. Two ideas that mean similar things land in the same neighborhood. Two unrelated ideas land oceans apart. That's the whole trick. Meaning, turned into a location. Let me show you why that's magic. On this map of meaning, dog and puppy sit right next to each other. Cat is close by. But tax form is way over on the other side. The computer never read a dictionary. It just measures the distance between 2 points. Close together means similar meaning. Far apart means unrelated. And it gets stranger. Because these are coordinates, you can do actual math on meaning. Take the vector for king, subtract man, add woman, and you land almost exactly on queen. The model learned the idea of royalty and the idea of gender as directions on the map. That is the quiet superpower under everything that comes next. A machine that can measure how close two ideas are. Upgrade 2, the vector database. Embeddings give you coordinates for one piece of text. But your company might have a million documents, so you need somewhere to store a million vectors and a way to instantly find the right ones. That's a vector database. Here's the payoff. Old search matched letters. You type car, it finds the word car and completely misses automobile, sedan, and my ride. A vector database matches meaning. You type car and it surfaces all of them because their coordinates sit close together on the map. You ask a question and the database hands back the chunks of text whose meaning sits nearest to your question. It's a library organized not by alphabet, but by what things actually mean. Quick, but worth it. How does it search a million vectors in a few milliseconds? It cheats intelligently. Checking your question against every single vector one by one would be painfully slow. So a vector database builds a web of shortcuts ahead of time, a network of links between points that are near each other. To find the closest matches, it doesn't check everything. It starts somewhere, then hops from neighbor to neighbor, getting warmer at every step until it arrives. This is called approximate nearest neighbor search. It trades a tiny sliver of perfect accuracy for being thousands of times faster. And that trade is the only reason searching meaning at this scale is even possible. Now, the unglamorous secret that quietly makes or breaks every one of these systems: chunking. You don't embed a whole 100-page document as one vector. You'd squash all of its meaning down into a single mushy point. So instead, you slice the document into small pieces, a few paragraphs each, and you embed every chunk on its own. Get this step wrong, and nothing downstream can save you. Chunks too big, and the real answer gets buried in noise. Too small, and you cut an idea in half, so it stops making sense. Nobody puts chunking on a slide. But ask anyone who has actually built one of these systems, and they'll tell you. This boring little step is where most AI projects secretly succeed or fail. Now we snap the first three parts together, and we get the single most important pattern in modern AI: RAG, Retrieval Augmented Generation. Big name, simple idea. Watch the flow. You ask a question. The system embeds your question into a vector. It searches the vector database and pulls back the handful of chunks whose meaning is closest. Then comes the clever part. It pastes those chunks right into the prompt and tells the model, answer using this. The model was about to take a closed book exam from frozen memory. RAG quietly turns it into an open book exam. This is how a chatbot can answer questions about your private files without ever being retrained. And because the answer is built from real documents you handed it, it's far less likely to just make things up. That's RAG. Give the brain the right page at the right moment. Here's why your first attempt at this often feels kind of dumb, and the pro move that fixes it: re-ranking. That fast vector search is brilliant at casting a wide net. It quickly grabs, say, the 50 chunks that are roughly in the right area. But roughly isn't good enough. So you add a second model. Slower, but much smarter. It's called a re-ranker. Its only job is to take those 50 candidates and carefully rescore them. This time, reading each chunk against your question far more closely. The best three float to the top. Wide net first, then a sharp filter. That two-step move, cheap and broad, then expensive and precise, is the entire difference between a rack system that feels random and one that feels like it genuinely read your stuff. People constantly mix up RAG with the other way to customize an AI. So let's settle it in about 10 seconds. RAG versus fine tuning. RAG is about knowledge. It hands the model fresh facts at the exact moment you ask, like passing notes into the exam room. It's perfect when your information changes often, or when you need the answer to cite a real source. Fine tuning is a different thing entirely. You keep training the model on your own examples until a new behavior is baked in. It's not for facts, it's for style, format, and tone. So here's the rule of thumb: if you want the model to know something, use RAG. If you want it to behave a certain way, fine tune. Most people don't need fine tuning. Almost everyone needs RAG. Everything so far gave the brain knowledge. But it still can't actually do anything. It can read your documents and then just talk about them. Upgrade 4 finally gives it hands. Tool use, also called function calling. You hand the model a menu of tools: search the web, run code, query a live database, send an email. When the model needs one, it doesn't pretend. It outputs a structured request. Basically, please run the weather tool for London. Your app actually runs that, gets the real result, and hands it back. And suddenly the AI can pull live data and change things in the real world. Tool use is the exact moment an AI stops being a talker and becomes a doer. But tools created a mess. Every tool needed its own custom wiring. For every different AI app, hundreds of apps times thousands of tools is a tangle nobody can maintain. So enter upgrade 5. The newest piece, MCP, the Model Context Protocol. Think of it as USB-C for AI. Before USB-C, every device had its own weird cable. USB-C made one universal plug. MCP is that plug for AI tools. There are two sides. A server wraps up some tool or some data, your files, your database, GitHub, and it exposes them in one standard way. A client like Claude or Cursor knows how to talk to any server. So you build your tool as an MCP server once, and every AI app that speaks MCP can use it instantly. No custom wiring. That's why MCP exploded. It turned that giant tangle into a single, clean port. Now we put all of it into a loop and we get the final form. The agent. A normal chatbot answers once, then waits for you. An agent is built to chase a goal on its own. It runs a cycle. It makes a plan. It takes an action, usually by calling a tool through MCP. It observes the result. Then it decides the next step and goes again. Plan, act, observe, repeat until the job is genuinely done. Give it a goal like research our top 3 competitors and email me a summary. It searches the web, that's a tool. It reads the pages. It might pull from a vector database. It drafts the email and it sends it. The brain in the jar now has memory, knowledge, hands, and the autonomy to use them. That's an agent. And it's everything we just built, running in a loop. So step back and look at the whole machine. Because now you can read any AI product on earth. When you drop a PDF into ChatGPT and ask about it, that's chunking, embeddings, a vector database, and RAG, all working together in under a second. When Perplexity answers with citations, that's RAG, using the live web as its library. When Claude connects to your Google Drive or your database, that's MCP. And when Cursor fixes a bug across your entire codebase on its own, that's an agent, looping with tools. Same 5 parts every time. Embeddings turn meaning into numbers. Vector databases search that meaning. RAG feeds it to the brain. Tools and MCP give it hands. And agents run the whole loop. That's not a pile of buzzwords anymore. That's a machine. And you can see every single gear. So here's where you are now. The next time someone drops embeddings, RAG, MCP, or agents into a conversation, like it's secret, forbidden knowledge, you won't just nod along. You'll know exactly which part of the machine they're pointing at and how it connects to the rest. You understand how modern AI actually works better than 99% of the people talking about it. And honestly, better than a lot of the people building it. Not because you memorized a stack of definitions, but because you can see the whole machine and how every single piece exists to solve the problem the piece before it created. If this finally made AI click for you, do 3 quick things. They genuinely help me out. Subscribe here on YouTube and follow Hyperautomation Labs on Facebook and Instagram. That's where I break this stuff down in plain English every day. I also turned this entire machine into a free 1-page decoder. Every part, every term, and how the real apps map onto it. Just comment the word machine and I'll send it straight to you. And if you want to go further, from understanding AI to actually building with it, my 4 guides are linked right below this video. Now go look at your favorite AI app and see the machine. I'll see you in the next one.